Scientists say an undersea volcano off the Oregon coast will probably erupt before the end of this year.
The Mariana Trench, ocean's deepest point, has always held secrets we've only begun to scratch the surface of. But the latest research has brought something disturbing to light. A volcano hidden in the depths of the ocean is growing more active by the day. Experts are now warning that by the end of the year, this volcano could erupt with enough power to cause devastation on a scale we aren't prepared for. The signs are clear and the clock is ticking, and this eruption could wipe out everything in its path. The Mariana Trench mystery. The Earth's surface, when viewed from above, can appear deceptively smooth, an ever-changing landscape of rolling plains, towering mountains, and vast oceans. But beneath the surface lies a world far more complex and dramatic. Just as we have peaks and valleys on land, the oceanic world has its own geological wonders. One of the most mysterious and captivating of these is the Mariana Trench. Stretching across the western Pacific Ocean, the Mariana Trench is not only the deepest oceanic trench on the planet, but also one of the most enigmatic. Spanning over 1,580 miles, this trench is far more than just a deep crevice in the ocean. It serves as a vital window into Earth's geological history. At the southern end of this colossal trench lies Challenger Deep, the deepest known point on Earth. With a staggering depth of over 36,000 feet, Challenger Deep is a place where light never reaches, and the pressures are so intense they could crush a submarine in seconds. To put this into perspective, the depth of Challenger Deep is nearly 3 times greater than the height of Mount Everest, the highest peak on Earth. In fact, if you placed Mount Everest at the bottom of this trench, its peak would still be submerged beneath miles of water. It's a place so deep it seems to defy our understanding of what is possible on this planet. But what makes the Mariana Trench and Challenger Deep even more fascinating isn't just their unimaginable depth. It's what lies beneath the surface. The trench is a crucial part of the Earth's plate tectonics, where the Pacific plate is slowly subducting beneath the smaller Mariana plate. This collision of plates creates immense geological activity, and scientists believe this is one of the reasons the trench holds such a wealth of secrets. Secrets hidden within its incredibly hostile environment. Yet the Mariana Trench holds more than just geological and biological wonders. Recent studies have uncovered a new and urgent geological mystery. In December of 2024, scientists tracking seismic activity in the Pacific Northwest, off the coast of Oregon, made an astounding prediction. They forecasted that an undersea volcano situated near the trench would likely erupt in 2025. This eruption, though occurring deep beneath the surface, could have profound effects, sending ripples through the surrounding marine ecosystems and potentially even influencing climate patterns. It is no small thing for scientists to make such a prediction. Eruptions of this magnitude are rare, especially those that occur beneath the ocean's surface, where monitoring is far more challenging. This growing volatility in this area has led scientists to predict that in 2025, axial seamount could unleash an eruption of significant magnitude. The possibility of such a volcanic event is intriguing, to say the least. Scientists are keenly watching, waiting to see how the forces beneath the surface of the ocean will unfold. What will the eruption mean for the surrounding ecosystems? Could it change the course of history in ways we don't yet understand? One thing is certain. The eruption of an undersea volcano in the Pacific Northwest would mark a monumental event, drawing the eyes of geologists, environmentalists, and the world at large. This is the history and geography of the trench and the early signs of volcanic activity that have scientists on high alert. Volcanoes under waves. Located just east of the Mariana Islands in the western Pacific Ocean, Mariana Trench is a geologist's wonderland, a region marked by both violent geological processes and an extraordinary diversity of life. What makes the Mariana Trench so geologically significant is its location within a tectonic subduction zone. Here, the Pacific Plate, which is part of the Earth's crust, is slowly being forced beneath the Philippine Sea Plate. This collision between the two plates is a critical component of the trench's formation and the resulting geological activity that continues to shape the region. The process of one plate subducting beneath another generates immense pressures and heat, making the trench a key area for understanding the Earth's inner workings. But the Mariana Trench is not merely a passive feature. It is an active zone where new geological phenomena are constantly being revealed. In fact, some of the most significant discoveries of volcanic activity have come from this very region. In December of 2015, a team of researchers made an extraordinary finding: undersea mud volcanoes and hydrothermal vents near Challenger Deep, suggesting that the region's volcanic activity may be far more dynamic than previously thought. These undersea mud volcanoes, with their bubbling plumes of mud and gases, are the result of complex geothermal processes taking place deep within the Earth's crust. Similarly, the hydrothermal vents, which release hot, mineral-rich fluids into the surrounding waters, are not only indicators of volcanic activity, but also unique ecosystems in their own right. These vents support strange and exotic species, organisms that thrive in conditions most life forms could never survive, conditions marked by extreme pressure, heat, and total darkness. The discovery of these features in the Mariana Trench was a crucial moment in our understanding of the region's volcanic nature. Researchers had long suspected that the trench, with its tectonic activity, might harbor signs of volcanic processes. But it wasn't until the findings of 2015 that these suspicions were confirmed. The hydrothermal vents, with their constant emissions of heat and minerals, are one of the clearest signs that volcanic processes are very much at work beneath the trench's depths. These features are especially concentrated around the Challenger Deep area, reinforcing the idea that this part of the trench is a hotbed of geothermal activity, where the Earth's crust is not only being stretched and compressed, but also undergoing constant transformation. These mud volcanoes and hydrothermal vents are significant in more ways than one. They serve as a living laboratory, revealing to scientists how volcanic processes unfold beneath the ocean's surface. More importantly, these phenomena also hint at the dynamic nature of the trench. The Mariana Trench is not a stagnant, dormant feature, but a constantly shifting environment, where geological forces are ever at work. This active nature aligns with ongoing volcanic activity in the Mariana Back Arc, the region just west of Challenger Deep. This back arc zone, where seafloor spreading occurs and volcanic eruptions are frequent, plays a crucial role in the region's geological landscape. The importance of these discoveries cannot be overstated. The Mariana Trench is more than just a geological feature. It's a living, breathing part of the Earth's system, constantly evolving and changing. And as technology advances, scientists are able to peel back the layers of mystery surrounding this deep, dark world. One such breakthrough came in 2015 when researchers aboard an autonomous underwater vehicle captured images of a pristine lava flow from an eruption that had occurred somewhere between 2013 to 2015. This eruption, located in the Mariana Back Arc, was significant not only because of its location, but also because of its depth, more than 4 miles below the ocean's surface. The lava flow, dark and glassy, was fresh, indicating that the eruption had occurred recently. The eruption was also accompanied by the venting of hydrothermal fluids, suggesting that the region was still experiencing significant geothermal activity. The findings were astonishing for several reasons. For one, volcanic activity at such depths is incredibly difficult to detect. Submarine eruptions are elusive. They don't leave the same obvious surface clues as eruptions on land. Moreover, these eruptions typically go unnoticed because they were often accompanied by smaller, less detectable earthquakes. But with improved technology, including autonomous vehicles and remotely operated systems, scientists have been able to document these undersea eruptions with greater accuracy. In the aftermath of the eruption, the region underwent significant changes. The hydrothermal system that had been active following the eruption began to cool, and the lava flows started to be colonized by a new ecosystem. This process, known as primary succession, occurs when new organisms start to settle and thrive in an environment that has just experienced a major upheaval. In this case, the venting system had already begun to decline by the time scientists revisited the site in 2016, but it still offered valuable insights into how life can adapt and flourish in the aftermath of volcanic events. The Mariana Trench and its surrounding areas are not just a geological anomaly. They are a symbol to the immense power and complexity of the Earth's volcanic activity. While we are talking about the region's volcanic activity, there have been significant volcanic incidents in recent history, such as the eruption of the Hunga Tonga Hunga Ha'apai volcano in 2022, which offers further context to the ongoing geological processes in the Mariana Trench. The Hunga Tonga eruption. On January 15, 2022, The Hunga Tonga Hunga Ha'apai volcano erupted in the South Pacific, causing an uncontrollable damage. The eruption proved to be one of the most powerful undersea volcanic events in recent memory, impacting both the environment and the lives of those in its path. For weeks prior, the volcano had been showing signs of activity. A smaller eruption on January 14 triggered a minor tsunami, barely noticeable to many. But the main eruption the next day was on an entirely different scale. The volcano released a violent eruption that lasted nearly 11 hours, sending a massive plume of volcanic ash and gases into the stratosphere. Shock waves reverberated through the atmosphere, and tsunami waves rippled across ocean basins, making this eruption a truly global event. The volcano, located about 65 kilometers northwest of Tonga's main island of Tonga Tapu, became the epicenter of one of the most extraordinary natural disasters in recent history. The eruption was assigned a volcanic explosivity index of 5, classified as very large. A significant tsunami, generated almost immediately, struck the islands of Tonga. It caused devastation. 4 lives were tragically lost, but the impact could have been far worse. The low death toll was attributed to the daytime timing of the eruption, early tsunami warnings, and effective public awareness efforts, which helped limit casualties. However, the destruction of property and infrastructure was immense. On Tonga Tapu Island, several resorts along the northwestern tip were completely destroyed. Other islands like Nomuka Iki, Mango, and Tonamea were also heavily impacted, with ocean surges flooding low-lying areas and wiping out entire communities. On Mango Island, not a single home survived the waves. The total damage in Tonga amounted to $118 million, mostly caused by the tsunami. The eruption itself also led to damage to agriculture and a vital sea-bottom fiber optic cable, but it was the waves that wreaked the most havoc. While the human toll was relatively low, the emotional and economic costs were devastating. The loss of homes, businesses, and livelihoods left deep scars, even as the world looked on in horror. What set this eruption apart was its ability to send shockwaves far beyond the immediate region. In addition to the local tsunami, the eruption triggered an atmospheric pressure wave that circled the globe. Tsunamis were observed on distant shores, including the Pacific coast of the United States and as far away as South America. This global impact highlighted the far-reaching consequences of undersea volcanic eruptions, showing just how interconnected the Earth's systems are. Despite the challenges, the eruption of Hunga Tonga Hunga Ha'apai served as both a tragedy and a learning opportunity. It reminded us of the hidden dangers beneath the ocean's surface, volcanoes capable of triggering events with devastating force. Yet it also showcased the strength of resilient communities and the power of modern technology. The lessons learned from this eruption are now informing research into volcanic tsunamis, enhancing global preparedness for similar events in the future. The impact of Hunga Tonga Hunga Ha'apai has had far-reaching effects, not just in the South Pacific, but across the scientific community. As researchers continue to study this event, attention now shifts to the Mariana Trench, where similar volcanic forces lie beneath the ocean's surface. With the possibility of future eruptions in the region, one question remains: will the geological activity of the Mariana Trench soon make its presence felt in ways we can no longer ignore? Predicting the next eruption. Off the coast of Oregon, a significant geological event is quietly brewing beneath the ocean's surface. Axial Seamount, an active underwater volcano located about 470 kilometers from land, is expected to erupt in 2025. While predicting volcanic eruptions months or even years in advance remains a rare achievement, Axial's behavior in recent years has given scientists the unique opportunity to make such a forecast, offering a glimpse into the future of eruption prediction. For over a decade, a network of advanced monitoring equipment has been recording every subtle movement of Axial Seamount, its rumblings, shakes, swellings, and shifts. These real-time data are transmitted via a seafloor cable, making Axial the most well-instrumented submarine volcano in the world. William Chadwick, a geophysicist at Oregon State University, and his colleagues have been at the forefront of studying this active volcanic hotspot, and in recent months, certain signs have caught their attention. In November of 2022, Axial's surface swelled to nearly the same height it had reached before its last eruption in 2015. This swelling is an indicator that magma is accumulating beneath the volcano. increasing pressure and signaling that an eruption may be imminent. This phenomenon mirrors what occurred before the 2015 eruption, which Chadwick and his team successfully predicted. The current signs, combined with increased seismic activity, a clear indication of moving magma, have led researchers to narrow their focus on a potential eruption in the next few years. The ability to forecast an eruption in advance is extraordinary, especially when most volcanic forecasting focuses on short-term predictions, often only hours before an eruption occurs. To make their predictions more precise, the team has developed a new tool that estimates the exact moment magma will burst to the surface. Additionally, artificial intelligence has been employed to analyze earthquake patterns that preceded the 2015 eruption, helping scientists pinpoint the early warning signals they should watch for in the future. This innovation raises the question, will the precursory earthquake detection methods be as effective as they seem? The stakes are high for volcanologists. If the AI model works as anticipated, it will provide invaluable insights into the behavior of axial seamount and allow researchers to deploy remotely operated vehicles to observe the eruption in real time. The ability to witness these processes firsthand could significantly enhance our understanding of underwater eruptions. While underwater volcanoes tend to pose less direct risk to human life than their land-based counterparts, they are not without consequences. The eruption of Hunga Tonga Hunga Hapai caused a massive tsunami that resulted in severe damage to property and people's lives. Tsunamis triggered by underwater volcanic eruptions can have widespread catastrophic effects on coastal communities, as seen with Hunga Tonga. With underwater volcanoes like Axial, false alarms are not a concern due to the relative isolation of the volcano and the lack of direct human presence in its immediate vicinity. The ability to forecast Axial's eruption is the result of years of monitoring and data collection, coupled with an understanding of how this specific volcano behaves. There is no crystal ball for predicting eruptions. Scientists rely on identifying patterns in volcanic activity and using these patterns to predict future behavior. For now, the focus remains on axial seamount, with scientists eager to test their methods and improve eruption forecasting. Each eruption provides a unique opportunity to refine these techniques, and Axial's relatively frequent eruptions make it an ideal case for understanding how underwater volcanoes behave. Whether or not Axial erupts in 2025, this prediction represents a significant milestone in the field of volcanic research. While it may not revolutionize the world of eruption forecasting, it will undoubtedly deepen our understanding of these dynamic and mysterious natural systems. And in doing so, it may help prepare us for future volcanic events in the Pacific Northwest and beyond. Exploring the deepest eruptions. The immense pressure and darkness of the Mariana Trench conceal volcanic systems with the potential to cause global-scale events, reminding us of the unpredictable and often destructive nature of these underwater forces. Beneath the ocean's surface, volcanoes like those in the Mariana Trench exert a subtle yet profound influence on our planet, reshaping ecosystems and ocean currents in ways we are just beginning to understand. The prediction of volcanic activity at axial seamount off the Oregon coast is a reminder of the unpredictable power of underwater volcanoes. Axial seamount is an active hotspot, and its eruptions, though less publicized than land-based volcanoes, carry the potential to disrupt marine ecosystems and trigger far-reaching effects. The ability to predict such eruption months or even years in advance highlights the growing importance of global monitoring systems for underwater volcanic activity. These systems provide invaluable data that help mitigate risks, protect coastal communities, and reduce potential damage. Yet the unpredictability of these submerged volcanoes remains a challenge. Previous volcanic eruptions like the Hunga Tonga Hunga Hapai eruption is a warning sign of the global consequences of underwater volcanic events. This eruption, though remote, sent shockwaves through the atmosphere and triggered tsunamis across the Pacific Ocean, causing destruction in places far from the source. Events like these show just how much we still have to learn about these deep-sea volcanoes. The future of exploration in the Mariana Trench and similar volcanic regions looks promising. Technological advancements such as autonomous underwater vehicles and remote sensing technologies are revolutionizing how we explore the ocean floor. These tools allow scientists to collect real-time data from depths previously unreachable, providing unprecedented detail about underwater volcanic systems. AUVs can now navigate the trench's extreme depths, capturing crucial information about volcanic activity, hydrothermal vents, and mud volcanoes, ecosystems that thrive in the most hostile environments on Earth. The exploration of these underwater volcanic systems holds more than just geological significance. The hydrothermal vents at the ocean floor, often located near volcanic activity, host unique ecosystems full of life forms that survive without sunlight. These ecosystems offer valuable insights into how life can thrive in extreme conditions and may even provide clues about the origins of life on Earth. Understanding how volcanic activity affects these ecosystems will also enhance our understanding of the broader environmental impact of underwater eruptions. In addition to scientific discoveries, the exploration of deep-sea volcanoes carries vital implications for human communities. As populations grow and coastal areas become more vulnerable to natural disasters, understanding the risk posed by underwater volcanic activity is more important than ever. With more accurate forecasting models, scientists can provide early warnings that could save lives and minimize damage to infrastructure. But predicting volcanic eruptions, especially underwater ones, is still an imperfect science. It relies on recognizing patterns from past events, but each volcano behaves uniquely. Despite these challenges, the continuous study of volcanic systems like axial seamount offers valuable opportunities to refine our understanding and improve forecasting models. Axial, with its relatively frequent eruptions, provides an ideal testing ground for scientists to test new theories and prediction methods. Looking ahead, the deeper exploration of the Mariana Trench and similar underwater volcanic regions is not just about gaining knowledge. It is about preparing for the future. As the Earth's volcanic systems continue to evolve, so too must our ability to monitor, predict, and understand them. The potential for new discoveries about the deep ocean, its volcanic activity, and the ecosystems it sustains remains high. The more we learn about these submerged giants, the better equipped we will be to protect both the planet and the people living on its shores. The next eruption, as predicted, could be the key to unlocking a deeper understanding of the forces that drive our planet. As we can see the growing danger under deepest point of Pacific waters, one thing is left to be answered. Are we truly ready for a catastrophe that could wipe everything in its way? Can we stop it, or will it be too late? What do you think? Share your thoughts in the comments below. And if you want to stay updated on what's coming, make sure to hit subscribe.